Hi children, welcome back to the maths class. So in the last previous videos we have discussed about the divisibility rules of 2, 3, 4 and 5. Yes? Yes. So today we are going to continue with the other remaining divisibility rules. Before we go into the class, let us once recall all the divisibility rules which we have learned in the last previous videos. Okay? So divisibility rule of 2. Divisibility rule of 2 is nothing but the last number of the given number. I mean, you can tell it as a digit also. You can mention it as a digit. See, suppose if 3, 4, 42, the last digit of the given number, if the last digit of the given number is 2, 4, 6, 8 and 0, if any of these 5 numbers are ending, then you can tell that it is exactly and completely divisible by 2. Okay. Next coming to the 3 divisibility rule. The 3 divisibility rule is nothing but if the sum of the digits in the given number, if that sum means what did I tell you? Yes, the addition answer. If that sum is divisible by 3, it means that the whole number is divisible by 3. For example, let us take one example. See here, 36. See, there are 2 digits here. This is a 2-digit number and you need to add them first. 3 plus 6. So when you add this number, what is the answer? Yes, it is 9. What is it? It is 9. If it is 9, is 9 divisible by 3? Yes, it is divisible by 3. So 36 is also divisible by 3. Yes. Now let us go to the divisibility rule of 4. 4 is nothing but the last 2 digits must be divisible by 4. That means, yes, I have taken a 4-digit number here, 2332, right? The last 2 digits are 32. Yes or no? If this is 32, it means that, if that is 32, it means that, is 32 divisible by 4? Yes, if 32 is divisible by 4, no? Yes, if 32 is divisible by 4, it means that the whole number is divisible by 4. Okay? And the last one is divisibility rule of 5, that is, in the divisibility rule of 5, the last number must be 0 or 5. The last number must be 0 or 5. Then only the whole number is divisible by 5. Is that clear, children? So, I hope you understood all the divisibility rules of the previous ones. Now, let us continue with the next number, 6. So, 6 actually is a number where you don't have a particular divisibility rule. It does not have a particular divisibility rule of its own. That means it is dependent. It is dependent on whom means, how can we write 6, children? We can write 6 like in terms of 2 times of 3. Yes or no? Yes. So, these are factors actually for this. I know that. So, but 6 does not have an individual divisibility rule. It depends on 2 and 3. That means if both the divisibility rules, if 2 and 3, if both 2 and 3 satisfies the divisibility rules, if both 2 and 3 satisfies the divisibility rules, then it is said to be that the number is divisible in 6. So, in order to learn in much more in detail, let us take one example and then let us go. Example 306. See, I have taken a 3-digit number here. Yes or no? Yes. I have taken a 3-digit number. In this 3-digit number, what is the last digit? Yes, 6. It is the 6. If it is 6, can you tell me, is it divisible into using your divisibility rule? Yes, it is divisible because among all that 5 numbers, 6 is also one of the number. Yes or no? 2, 4, 6, 8 and 0. So 6 is one of the number which should be in the ones place. So if this is present, it means that it is divisible by 2. So this number satisfies the 2 divisibility rule. Is that clear? Yes. Now it should satisfy the 3 divisibility rule also. That means the sum of the digits. Sum of the digits. What is the sum of the digits here? 3 plus 0 plus 6. What is it? Can you tell me the sum? Yes, 3 plus 0 is nothing but 3. 3 plus 6 is nothing but 9. So, 9 is a number where it is divisible by 3. That means the same number satisfies 2 divisibility rules. the 306, the given number, satisfies two divisibility. That means 2 and 3. It means that this 306 is divisible exactly and completely by 6. So did you understand that? So 6 does not have a divisibility rule of its own. It depends on 2 and 3. That means both the divisibility rules should be satisfied in order to be divisible by 6. Did you understand, children? Yes. Now, let me go with the next number. So 7 does not, 7 actually has a divisibility rules, but it exists only up to 100 numbers. That means it exists only up till 99. That is the 2-digit numbers. It does not exist more than that. Yes or no? So next we are going to learn 8. Okay? Yes. 8. 8 divisibility. 8 is also in the same way as we have learned the 6. See, these does not have the divisibility rules of their own. So they started slowly depending on one another in order to make their divisibility rules. So see, how can you write 8? We can write it as 2 times of 4, right? So when you write 2 times of 4, it means that, what did I tell? How did we learn 6? 2 times of 3. So both the divisibility, same order. See, the number, given number should satisfy both the divisibility rules of 2 as well as 4. Then only it is divisible by 8. So let us take one number here. 224. If I take a number 224, what is the last digit present here? Right, 4. Yes. So 4. As the number, given number, in the given number, then there is a digit called 4 in the last place. It means that, is it divisible by 2 or not? Yes, it is divisible by 2. It satisfies the divisibility rule of 2. Yes. Now let us check with the divisibility rule of 4. Let us check with the divisibility rule of 4. What is the divisibility rule of 4? Yes, the last 2 digits should be divisible by 4. Yes. See the last 2 digits. What is it? 24. Is 24 divisible by 4? Yes, because you can see it in the 4 table. That is why it is divisible exactly by 4. So this number satisfied the 2 divisibility rule and 4 divisibility rule. Ultimately, it is divisible exactly even by 8. So as the number, as you check, you need to check 2 divisibility rules, children. If you may get a doubt, miss, if suppose there is only one divisibility rule, suppose let us take one example regarding this. If only one divisibility rule it satisfies, and if it does not satisfy the another divisibility rule, then what happens? So let me take one example regarding that also. Yes. So if you take an example of 3, 5, 2. So instead of 5, let me write 6 here. Yes, let me write 6 here. So if you take a number of 362. If you take a number called 362, children, actually the ending number is 2. Yes or no? The ending number is 2. So it satisfies the 2 divisibility rule. But if you take this 62, it is not exactly divisible in 4. Did you understand? It is not exactly divisible in 4. You can divide and see it. Let us check it here. 4, 62. How many times it will go, children? As the first digit of the dividend is greater than the divisor, so you can go with the 4 table. 4 ones are 4. And 6 minus 4 is 2. Then you get down 4 5s are 20. So it is 2. So it leaves some reminder. So if it leaves some reminder, what do we tell? It is not exactly divisible by 4. So see, it is divisible. The divisibility rule of 2 is okay, but the divisibility rule of 4 is not okay. It means that it is not divisible by 8. In order to satisfy the divisibility rule of 8, you must satisfy both the divisibility rules, not one, children. Not either or. Okay, not neither nor. You should satisfy both. Compulsorily, both the divisibility rules should be satisfied in order to conform or to satisfy the divisibility rule of 8. Did you understand? Yes? Yes. So now let us go into the next divisibility rule. Now the next divisibility rule is 9. If you take the divisibility rule of 9, this is the similar as of 3. But there we tell if you add the sum of the digits, that sum should be divisible in 3. But here, if you add all the sum of the digits, that should be divisible in 9. So, the sum of the digits, sum of all digits of the given number should be divisible by, should be divisible by 9 here. There only with 3. Is that clear? Yes, because 9 table is different and 3 table is different, no? Yes. So 3 plus 6 is 9 and 9 plus 9 is 18. Yes. Is 18 divisible in 9 table, children? Yes, it is divisible in 9 table. So you need to confirm that if the number, see, if you get suppose any other number like 6 here, this is 18, it's okay. But for example, if you add something, 3 plus, 33 is there, and if 3 plus 3 is nothing but 6. 6 is divisible in 3. So, 33 is divisible in 3. It satisfies the divisibility rule of 3. But it does not satisfy the divisibility rule of 9. Did you understand? Yes? Yes. Is that clear now? Yes. So, once again, the divisibility rule of 9. The sum of all the digits, must be divisible by 9. Then only the whole number, the given number, is divisible by 9. So, did you get the divisibility rule of 9, children? Yes. Now, let us go into the divisibility rule of 10. When you go with the divisibility rule of 10, you all know that the number should always end with 0. Yes or no? So, the number always should end with a 0. The number should end with 0. Okay, so if you have any other number like 5, suppose if I take an example of 300, the last number is 0, so it is divisible by 10. Yes or no? As the last number is 0, it is not only divisible by 10, it is also divisible by 5, because it satisfies the 5 divisibility rule also, where the last number is ending with 0 or 5 means it is divisible by 5, no? So, it means that this 300 is not only divisible by 10, but it is also divisible by 5. But if you take another number, like suppose which is ending with 5, this number is ending with 5. It means that it is divisible only in 5. It is not divisible in 10. Did you understand? The common thing is if the number is ending with 0, it will satisfy two divisibility rules, 5 and 10. But if it ends with 5, it will satisfy only one divisibility rule, that is 5. Okay, did you understand, children? So here we are closing with all the divisibility rules, and in the next video we are going to enter into the topic of factors and multiples. Share, like and subscribe. Thank you.